Hey, I had a request for number 7, so thought I would go ahead and work this out for you guys. The first thing I would do on this one is change this, the e part, to e to the y times e to the sine x. So using that little trick where you're adding the exponents, so going the other direction, writing it as a product with a common base. Now you can split and put the y on the left. So I'm going to have 1 over e to the y dy equals cosine x e to the sine x dx. And then from there, I'm going to write this as e to the minus y dy. And on this side, we're going to use a u substitution. So notice that the derivative of sine is cosine, so I'm going to let u equal e to the sine x. Let me rephrase that. That was not right. Is sine x. So du is cosine x dx, which we have there. So now we have e to the u du, and I'm going to do the antiderivative of both sides. So here we just get negative e to the negative y, and here we get e to the u plus a constant. Let me fix this here so we can see it better. Well, that didn't help. Okay, so now we have to put back. So we have negative e to the negative y equals e to the sine x plus a constant. And then my values were 0 and 0, so now I'm going to plug in the 0 and 0. So negative e to the 0 equals e to the sine 0 plus a constant. E to the 0 is 1, so we get negative 1, and sine 0 is 0, so e to the 0 is 1. So that tells me that the constant when you subtract 1 is negative 2. So now I have negative e to the minus y equals e to the sine x minus 2. So I'm going to multiply both sides by a negative 1, so I get e to the minus y equals negative e to the sine x plus 2. And now I'm going to natural log both sides. So we have ln, and it's of this whole thing. So then that cancels this out and leaves me a minus y equals ln. And because of that, you can't distribute, it's not 6 though, you can't distribute the ln, remember? So you can't, you can't simplify that part. So then I just want to solve for y. So we get y equals negative ln, and you can put the 2 first if you want, 2 minus e to the sine x. Okay, so this is what I got for an answer. Now looking at the answer book, they say that there are no restrictions on the domain. However, I do have an issue with that statement, and that is that it is possible sine x, remember that sine x is bound between negative 1 and 1. So if it's a negative 1, then this is no big deal because then we would have e to the negative first power. It would be the reciprocal, and it's going to be a positive value. But if sine was 1, then you get sine, if sine of x was 1, you would get e to the first power. And if you do 2 minus e, you're going to get a negative, and you can't take the log of a negative. So I'm going with this. 2 minus e to the sine x has to be greater than 0 because you can't take the log of something 0 or less, which means that 2 is greater than e to the sine x, which means that ln 2 is greater than, if you natural log both sides, that would cancel out the e. So sine x has to be smaller than ln 2, which ln 2, remember we said that sine x could go all the way up to 1. Well, not according to this, because if it did, it would be negative. And now you could solve for x, but then you get into this because it would be this, x is less than inverse sine of ln2, but then I'm pretty sure too you have to deal with the fact that you're talking about, well, let's see what happens. Inverse sine of ln2. But then you would get into the issue of this is the whole thing with sine x being a oscillating function, and so we're not going there. This is the answer, and we won't worry about if there were any restrictions on the domain. And if there were restrictions on the domain, I would stop right here, and this would be implicit really and not explicit for x. But anyway, hopefully that answers the question as far as how to do that problem.